So this is our gear D, right? Now gear D, right, it will engage another gear at gear H. Okay, so this is my gear D. Okay. And then it will engage another gear, which is our gear H. So I'm going to sketch out our gear H. Okay, so this is our gear H, right? So this is our gear H, right? So the force, the position of the force, okay, is located where the two gears are engaged, okay? So there's two possibilities now, right? So one is the forces can be acting in this direction. So this is your gear D, right? Or the forces can be in the other direction like this. Okay. So anyone, any questions so far? Anyone? We're okay? Okay, so now is the time to focus, okay? So you look at force E now, right? Hey, what am I doing? Come on, Eugene, stop messing around. Right, you look at force E now. Force E, the applied force to the system is going downwards at that direction, right? And it's going to generate a rotation about this direction over here. Okay, look at this rotation, right? So every gear is working at that direction. So now the question is, the force at point D, is it going towards the left-hand side or is it going to the right-hand side? So I'll tell you the answer now. Okay, some of you already know this. The answer is going towards the right-hand side. So this is the correct one. This is the wrong one. Okay. Why? Because the force at D must be a resistance to force at E. It must resist. It cannot follow. Why is that? Okay. If it follows, so for example, if this is 30, if this FE is generating, we know it will generate 30 kilowatt, right? FD over here now will resist by what? So at at point D is what? It is related to H. This is what? 10 kilowatt. So the net, right? The net will be equal to 30 because it's in opposite direction minus by 10 kilowatt is equal to what? 20 kilowatt. Okay. So this is based on this arrow over here. So this is based on this arrow over here. And the net, okay, the net will be wrong. If you say that is towards the left, I'll tell you what's the problem. So if you say that it's towards the net, it's towards the left, so it's 30 kilowatt plus by 10 kilowatt is equal to what? 40 kilowatt. You see where the problem is? You cannot, by the law of physics, it cannot just by somewhere, somehow, something have to generate resistance will add to the system. No, it will have to what? Subtract from the system. So that is why this is wrong. And with this mindset of thinking, that is why FD is in the what? In the opposite direction. Okay, as I said, a lot of students make this mistake, unfortunately. Okay, they thought that if FE is coming down, everything will follow direction. No. Okay, so now if we were to, so far, are you all okay? Yes or no? Anyone? You have any questions? No one have questions? Okay. Yes.
Eugene.
Yes.
So does the driven force always oppose the driver force, like
Yes.
regardless of where the mesh of the two gears are?
Yes. So good question. So if let's say we have the same system, okay, let's say we have the same system. So I'm going to draw the entirely the same system. So let's say if we have, this is our gears again. Okay, this is our gear again, right? So exactly the same. Okay, so again we have a small gear over here, exactly the same system. Okay, now I'm going to change our gear H position. So now uh this is the ping. So one, bear with me, okay? Okay, so everything is still the same, right? So our FE is still coming down from here. Now our gear H, so for example, this is a different configuration now. So our gear H now, we decide to put our gear H over here. So this is our, sorry, there is our, yeah, this is our gear H now. Right? And we know the rotation of the shaft will still be in this direction, yes or no? Right? So don't focus too much on the rotation. No, you have to watch the rotation of the shaft, not don't focus. Okay, so if this is our shaft, right? Now, right? So this is our gear D. Okay, so that is our gear D. Okay, so now this is our gear D. Right? So now, how will our force be applied? It will always resist the what? The rotation, right? The only way that it will resist the rotation, gear or FD will now have to behave this way. So where the two gear meshes, this is your direction of FD. Does that answer your question?
Yes.
Right? It will answer because all this, right? So if I draw gear, right? So this is the direction of rotation, right? So FD will generate a what? This will generate a resistance, right? This is from the what? This direction, direction based on the applied motor. Okay, so you really have to embrace this analysis, or not everything is like wrong. Okay, everything just go crazy. Okay, but now you see the logic behind it. You see the explanation behind it, especially this case. So this is the logic behind it. If you want to talk about logic, this is the logic. So the net is what we want to look at. Okay, so we know that 30 kilowatt is the input. Everything will be drawn out. Okay, so drawn out means ultimately the entire system will have a net force of what? 0. Okay, so the in is 30, the out must be equal to what? 30 also. Conservation of energy. Okay, so from here we also know, right, gear C and G, where the mesh meet, we also know that this will be the direction, right? So this is our force. Oi. So we also know that this is force at point C. Okay, again, the position is based on the mesh, when two gears are meshing together, and the direction is to resist the applied torque or the applied force. Okay. Any questions so far? I hope you are clear with this, because as I said, the last time I taught this course, a lot of students did not see this at all, and it's sad. Okay, I want you to be able to see it. Any questions so far? Anyone? No? Okay, so from here, so I'm going to view. All right, I'm going to take this whole thing. Right, so this is the direction that we analyze. Okay. So believe it or not, right? If this is wrong, the whole problem set, yeah, you're done. Game over. Okay, you're done. Okay, you will not spec the right size already. That's why this is so critical. So if you look at the textbook, okay, oops, I got the wrong page. It's okay. So if you look at the textbook, the solution from the textbook, right? So if you look at the solution from textbook, right? This is the solution. Okay. So I want you to watch at point D and at point C what direction. Okay. So it's exactly as the same direction as we specify. Okay. Right. So from here, so now you can we can explain, or there's a logic behind why the forces are acting in this direction. Okay. Later on, then we deal at the reaction at point A and point B. So let's focus on the shaft first. So from here you can start analyzing. Okay. So power by motor. So power input by motor. This is equal to 30 kilowatt. Okay. Then you have power output through gear C, right, which is given to us. So at gear C is given to us at 20, yep, 20 kilowatt. And power output by gear D is equal to 10 times 10 to the power 3 watts. Okay. So we are given that the shaft AB rotational speed so the rotational speed is equal to 480 revolution per minute. So this is given to us. Okay, this is given to us. So let's look at the question. If we look into the question, right? So all this information I extracted from here, right? That's where we get our 480 from, right? 30 kilowatt, 20 kilowatt, and 10 kilowatt at H. Okay, so H is related to D, G is related to C. Okay, so we want to find. So we know we have a very simple formula to apply where power, right? Power. So now the thing is what? How are we going to relate? How to relate? Okay, how to relate power, torque, and forces. So at the end of the day, we want to know what is the force applied, right? We specify down here. We always want to know what is the force, and we also want to know what is the torque. So the power, the formula to apply, I think all of you have drawn electricity at a time or another. So we know that power is equal to 2 pi nt over 60, right? Where n